Hey guys, hi everyone. Welcome to the session. Today, we're going to talk about a self-served, cost-driven data engineering systems at MiQ. Myself, Rohit Srivastava, I am one of the engineering managers at MiQ. I currently lead the data engineering team in our organization. Uh, I have with me one of my colleagues, Bitanshu. He also is one of the lead data engineers. And we're going to take you through the self-served, cost-driven journey of data engineering systems and how MiQ has driven that. Coming to the agenda, I think we'll cover probably an introduction to MiQ, what MiQ does, and what's our expertise areas. We'll talk about our data analytics ecosystem, how does it look like, and some of the challenges in terms of our data processing suites and how over a period of time we have tried to kind of fix some of those things. After that, I think Bitanshu will try to cover the three core pillars of cost management. I mean, as an organization, we have laid those pillars and we live and try to breathe by these pillars: cost optimization, cost reporting, and cost debugging. We try to go deep dive and share a lot of knowledge that we have gained in past, let's say, a couple of years or so. And then we'll try to conclude by some of the wins. With primary focus on how these wins have helped us balance the whole COVID state of area. Right? Cool. So let's moving on. So about MiQ, who we are. So for us, MiQ is an independent marketing intelligence company with the people and the technology that help business win. And how do I say business win is that we typically help the clients get onboarded and increase their reach in terms of programmatic media spend, right? So think about it that if there is a client and if he or she or as an organization, you are releasing a product, right? And you want to increase the reach of that product through digital advertisements or digital boards or let's say TV advertisements, then we as a company partner with you to make sure we understand your reach, understand your use base, create campaigns out of it, and then make sure that your richness is diversified as much as possible, right? So let's put it that way, that we are a programmatic media buying company who help the company increase their marketing intelligence. Moving on, what specifically do we do? Our offering is basically combined into three different vertical pillars, one being media, second being analytics, and third being technology. Combine all of these three together probably helps in applying the whole marketing intelligence media to our customers, right? And derive insights that can help take their products and the reach to the market in a much better shape. So talking about the first pillar, which is media, as I mentioned, that if you have a product released, and let's say if a client wants to increase the reach of that, then we as a company help you increase your brand growth, right? And increase your higher sales, make sure that your programmatic ad and the campaigns and the revenues are reaching to a lot of the people. So let's put it that way, that we fuel your campaign to reach to right set of people at right set of the time. That's our media offering. Second offering is analytics, and that's where slightly different from media, where we look out for the clients who have a very rich data stores, data warehouse, and then they want someone who can help them drive good data decisions or generate good insights out of it. And that's where our very specific solution are analytics, where we go out to the customers and sell our custom analytics solutions. So think of it that we kind of act as a data lake enablers for our clients who come and onboard with us. So that's our analytics offering. Third part is technology. I think unlocking the value through any data we get. And it's not specific to clients. I think our technology is built, or let's say the services are built in a way so that we enable our traders, solution engineers, as well as commercial guys to take any decisions in a real quick manner, right? So think about it in terms of real time bidding. If you are trying to place a slot and you are kind of bidding across millions of users, we tend to build technology that can enable our traders to bid in much more real time with the right set of price and the right set of insights, right? So that kind of summarizes our three different offerings as an organization: media, analysis, and tech. Uh, this is our data lake architecture from the analytics side of things. Just to start, I think it's divided into two core pillars. We have something called as foundations, and then we have something called as enablers. What you're seeing in the bottom are two core services. One is called cluster management service, and the top service that sits on above that is called notebook execution service. We also call it as data processing service. We use different providers in terms of big data management. We use AWS. We definitely use Qubole along with some of the other big data managed providers. So we have something called as cluster management service. This service is an abstraction on top of all of these providers to have an ability to launch the clusters. So basically, abstracted cluster management service for the users to use. On top of that sits your query execution engine. We have named it Notebook Execution Engine. We also call it internally as Data Processing Engine. Basically, a query interface which allows you to abstract out the technology and just you give the needs, and internally it will take care of executing it either on Hive or on Spark or on Thales, Presto, Athena, and decent amount of technology stack that we talk about. Above that is something what we call as an enablers layer, and there is a vertical segregation of all of these. And our vertical architecture looks like prepare, learn and deploy, execute, test, and monitor. It's a combination of predictive analytics as well as modeling. So if you see the first vertical layer, which is data preparation, right? So basically the ability to prepare the data, and that's where all of these small boxes that you see, these are individual microservices that exist in our ecosystem of tech right now. So examples are data transformation service, data preparation service, feature engineering service. And feature engineering service obviously is a wider domain, but there are a lot of other things like feature importance, feature outlets, etc., that goes around this. Second vertical being learn and deploy. This is our typical model deployment microservice. And as you can see, the microservice is called modeling service. And then there are tons of things that it does, right? Your model execution, your model optimization, model selection, combination of model, your model deployment. So in general, an abstracted microservice which can take care of your modeling in general. Then you have execute. Once you have deployed the model, you need an ability to basically execute a model. And that's where a lot of microservices around that, which is an ability to predict based on your model, based on multiple algorithms, then ability to cluster your algorithms, ability to do some amount of experimentation. And then you have subsequent test and monitor phase where you should be able to validate your model before you bring it to production. At the same point of time, an ability to monitor your production, monitor your model whenever it has gone into production. So that's the monitor level. And this is how our data lake architecture from the analytics side looks like. And as you can see on the left side, that there are three different kind of stakeholders that uses this entire data lake. What we call the first one is CAPS. CAPS is nothing but capabilities. There are a lot of microservices sitting on top of this architecture that would try to consume that. Then you have apps, which is your typical application. We have a lot of reporting application, trading application, real-time and insight application that again are a typical stakeholder to this whole data lake architecture. Then you have something typical users, our analysts and data scientists. They use this ecosystem pretty exhaustively for their day in, day out automation or interactive execution. Just to give you a brief introduction to how the scale at MiQ currently looks like, we kind of serve roughly around 90 to 95 billion ad impressions per day. Our volume of the data has increased tremendously. Like about 2 years back, we used to be somewhere around 7 to 8 terabytes of data. Currently, we stand at 30 terabytes of data ingestion per day, right? Some of the other ad-related metrics, like our CPU stands at close to 1 million, then amount of users that we target are like tremendous. What you can see here is our last 1 year of data where we have tried to target 750 million of users. 5,000 plus strategies, 5,000 plus campaigns. Just to give you maybe a glimpse of what a campaign and strategy is, that for every different kind of client, you need to come up with a different strategy to target a user. You would want to target a user based on his or her movement. You would want to target a user based on his or her, let's say, TV watching capabilities, right? What he's watching, what he's not. You'd want to target a user based on his online purchases, right? So that's where we are saying that we build kind of multiple strategies, and based on various domains and various spaces that we operate in, we at this point of time have close to 5,000 plus strategies around, right? And in order to adhere to this amount of scale, volume, variety, what you need is what you're seeing on the right side, right? You need a quality level of insight. You need multiple languages and tools. The richness can be expanded. That we use Java, Scala, Kotlin, Python, Spark, Athena, and whatnot, right? Data mutation and copies are very tough nut in itself to handle, right? And then scale. And scale is known only about the data. For us, the variety and veracity also plays an important role. Our campaigns are very distinctive. It's just not about domains, but the nature of campaigns that we have. Varied experience levels is an important aspect to look at. And with the recent incoming of the whole GDPR thing, I think the compliance of data governance become a very important aspect around this as well. So this is a brief kind of overview of how the scale and the use of technology kind of mix together for us as an organization. Okay, entering into the main thing, I think for us, speed, quality, and cost are the holy trinity of any data processing stack, right? And we all are engineers, and I'm pretty sure most of us would know typical what a CAP theorem is, right, in database algorithm and consistency, availability, and the partition tolerance, right? And the theorem very well says that you cannot achieve all three at any one point of time. For us, the rule is similar kind of rule applies to the speed, quality, and cost. That it is literally impossible to basically achieve a perfection around all three circles together, right? And that's where what we say is that in order to produce an outcome of a certain quality at any given point of time, you have to figure out of these three which is more important. And that's where I think we very much believe in what you're seeing the quotation here, right? That how much cost inefficiency are you willing to tolerate for a given amount of quality and speed, and thereby making your cost monitoring a very key aspect for a good data engineering culture. And as an organization and as a data engineering team, we try to live and breathe by this principle, right? That at any point of time, quality and speed are very important, but it cannot come at the compromise of our cost, right? And that's where for us, this kind of sets us to give a momentum about the talk that we are going to do. And that's where our prime focus going ahead is going to be on the cost aspect and how we make sure that our cost is not taking a toll over quality and speed of deliveries. I mean, yeah, just a way to put it, I think with great data, which is close to 30 petabytes of data per day, comes gate processing cost. Just trying to give a visualization where it used to be one hardware. From one hardware, you have literally bloated up, and then now there is a cloud. And at the same point of time, if you linearly extrapolate, you used to be in pennies, and now organization has to be, I mean, in terms of their cloud expenditure or your data engineering expenditure, it's literally like going down millions of dollars per month. Correct? So yeah, I mean, that's kind of trying to give you an aspect of how much cost is becoming important as in your data processing stacks keep on optimizing, growing technology. Cool. So with that, I would pass it on to Bitanshu. He would try to take you through in details around how the whole cost management aspect works for us as an organization, and some bit of journey around technology of how technology evolution has helped us to manage this cost overall. Passing into Bitanshu.
Thank you, Rohit, for taking us through what MiQ does and why do we need cost management. So here, hi guys, I am Bitanshu. I am one of the lead data engineers at MiQ, and I will be taking you through this journey of cost management. Might not be a magical journey, but it will be a methodical journey. Life. Now let's start with the three pillars of cost management. The first one is cost optimization, followed by cost reporting, and final one is cost debugging. These three constitute the pillars of cost management at our organization. So when we are starting the journey of cost management, we wanted to make sure that it's a self-served thing so that we don't have to specify a specific team that would look at the cost. It should be incultivated as a culture in our organization so that each team can look up to its cost metrics. And for that, we needed all these to be a part of automated job so that it is self-served, and whenever a team or a user wants to see how much he has used, how much cost he has taken up for the resources, he can just go and check it himself rather than relying on some other team. So cost optimization, as it said, performance and cost are the first class citizen. So first major step in our cost management journey was pipeline optimization. In MiQ, we were mostly making use of legacy products such as Hive for our ETL pipelines, Amazon Redshift for our interactive queries, and Apache Druid that was also for interactive queries for a specific product used for retargeting. Amazon Redshift was also used for one of our older products that was for reporting. From Hive, we shifted to Spark for our ETL pipelines, and from Amazon Redshift and Apache Druid, we made sure that our interactive queries are based on Presto. We also migrated the backend of these legacy products to Presto. What were the benefits that we see from these exercises? So when we moved from Hive ETL pipelines to Spark ETL pipelines, one of the major benefits that we saw was lesser IO operations that were taking place in Spark engine. Spark being an in-memory computation that the pipelines benefited from this. Now lesser data had to be written due to, for intermediary steps in S3, which took much time when using Hive. Due to this, the processing time was reduced. Also, this increased our pipeline stability, as sometimes we faced issues with S3 eventual inconsistency error. Now pipelines were more stable since the connection between S3 to your Hadoop engine was reduced. There was also reduction in 30% of production processing cost. The real-time predictive and retargeting was moved from Druid and Kafka to Kinesis and Spark. This resulted into around a savings of $4,000 from terminating the Druid setup. The Redshift, now being lesser used, could be downgraded to 5 nodes from the earlier 10 nodes. Uh, this setup also helped us to achieve better monitoring and alerting. The Tableau dashboards also were moved from Redshift to our Presto. Presto also provided us this scalability of these data sets that were being used in Tableau. Now we could scale up our clusters according to the data sets that we're ingesting. The reporting tool and the retargeting tool were also migrated from Redshift to Presto. The reporting tool showed a 35% better SLA for report downloads. We could increase the look back period of the reporting tool from 1 month to 3 months. This was because now the data need not to be stored in both Redshift and S3, but we just could rather specifically query from S3, and we could the storing of the data was also much cheaper now. The better and consistent performing queries were seen in targeting tools. This was because sometimes in targeting tool, there were multiple users were hitting the Redshift at the same time, which caused bottleneck in our operations. Presto, with a better queuing mechanism of queries, made sure that the queries were not failing much. The migration from legacy tech resulted in improved performance and over $100,000 in savings at minimal incremental costs. Next uh, in our journey was pipeline optimization. So this happened in 4 different steps. First was monitoring and memory optimizations. Then we used more optimized file types or modern file types. We optimized our joins, and we placed checkpointing and caching in our ETL pipelines. So in monitoring memory optimization, that was a long tedious operation that we carried out manually. With around 30 days of manual operation, we monitored the ganglia matrices of various ETL pipelines and the cluster that they were running on. Finding out this, we could suggest changes in the ETL pipelines. Some suggestions were like upgrading or downgrading a cluster instance type as per a requirement. So for example, you are using instance using a ETL pipeline which were taking like more number of executors. So you change your heavy memory based computation EC2 instance to a more where you get more number of executors. Similarly, going through R&D pipelines, we see major use of pandas data frames. These data frames are computed in driver memory, which requires significant amount of driver memories, and parallelism of the job is also affected. So we converted these panda data frames into Spark data frames so that uh, not only the scalability is easier, but also we can the parallelism is better, reducing the overall query time. For memory optimization, we we upgraded or downgraded various memory parameters such as the mapper and reducer memory, the optional Java memory, and executor and driver memory. For optimized file types, earlier we used to use text files, the traditional text file that we use, and now we from text files we migrated to more optimized row columnar based file types such as ORC and Parquet. These file types not only were faster to read and write, but also they were more optimized how they were stored on S3, and also the query performance was much better on these types of file types. For join optimizations, we use the concept of bucket join, where uh, we use the concept of bucket join. We use the concepts of broadcast join. We use sorting and sorting the data sets before complex joins. And we also for skewness of data, we use the concept of salting. These join optimizations will be covered by Vikas and Jatin in other session. So please tune to that. In case of long ETL pipelines, we provided checkpoints in the middle. These checkpoints were not only the caching of our data frames, but also making sure that intermediate steps are written into S3. This made sure that we, whenever if there was a failure of jobs in between, we didn't have to start from scratch, but we can start from the checkpoint. Once all these pipeline stability was performed, we moved our focus to storage optimization. As the storage cost keeps on increasing, we had to make sure that we do something about the ever increasing S3 cost. So first in this line was file format optimization. As we already mentioned, from we moved on from historical text files to more modern and optimized ORC and Parquet file systems. We also made use of compression, such as Snappy. Earlier, most of our data was compressed with gzip format. Gzips are notorious for being non-splittable. When using Snappy, the compression percentage was not as high as gzip, but we received better overall performance in our ETL pipelines. Then we also cleaned up our older data. S3 cleanup was carried out, which cleaned our historical data. Some of the data that was stored in our S3 dated back uh, as long as to 2014. Similarly, for important data which needs to be archived were shifted from S3 to Glacier, which also resulted in major cost savings. Uh, at MiQ, at first we were giving the user the freedom to launch their own cluster as per their needs. But major disadvantage with this process was that there were a lot of cluster uh, resource wastage. When we were going through the Ganglia matrix of various clusters, we saw that most of the clusters had their resources remain idle, and only 5 to 10% of these resources were being utilized at a point of time. So we introduced the concept of shared clusters. So as we partnered with various other data providers, so there were better features of auto scaling involved rather than the traditional AWS auto scaling feature. So this helped us to you make the use of minimum and maximum number of nodes so that the resources are better utilized, and users can already take advantage of already running clusters and run their query faster on them. Similarly, we at a point of time had different Presto cluster for each account. But the major disadvantage we saw was that on there were we needed to have certain number of minimum number of nodes always up. So for example, if you have like two number of minimum nodes for one Presto cluster, for 7 accounts you have like 14 minimum of number of nodes that were up all the time. To mitigate this, we made sure that we have a one unified single insights cluster which Tableau can connect to, which benefited that the minimum number of nodes could be increased, but still we could be saving lots of cost according to the number of nodes. So for example, rather than keeping up 14 number of nodes all the time, we could now end up keeping only 5 number of nodes and still end up saving cost. Similarly, we migrated uh, to the concept of unified interactive and unified ETL cluster. The ETL clusters were used for our schedulers, whereas the interactive clusters were used by users for interactive queries. So now let us move our focus. Now, how did we do our resource optimization? So at first we are using on-demand instance types as for our clusters. So on-demand instance types are actually fluctuating according to our market prices, which could eventually cost us quite a lot. Spot instances are actually fixed price instance where we could save around 80% of the cost compared to on-demand pricing. For important ETL pipelines where we could see that there were issues of spot loss, we made sure that there were spot reserves. Some of the instances were reserved for our important jobs. Similarly, for heterogeneous clusters, the concept of the cluster requirement of your resources was introduced, where you don't have to worry about your cluster instance types, but rather worry about your cluster resources that's required. So for example, our R5 X large instance has 4 number of cores and 32 GB of memory, and whereas the R5 2X has 64 GB of memory and 8 number of cores. So rather than using an expensive R5 2X large at one point of time, if you have like 50 number of nodes, you can use 100 number of R5 X large instance. So there was also, since the auto scalability of our third party data providers were much efficient, we could use our min max number of nodes for better resource utilization. So now users didn't have that benefit of launching as many number of nodes as they required, but the infrastructure decided for them that how much number of nodes is required, and hence we could uh, allot them that much minimum and maximum number of nodes. Also, we saw that during weekends, the number of usage, the amount of users of clusters is very high, very low. So we could make sure that during the weekends, the clusters are downgraded. The minimum number of nodes is decreased. So a script was written to carry out this task so that each weekend the clusters are downgraded. Similarly, for efficient upscaling and downscaling, as I've already mentioned, we could have better resource utilization. The auto termination and timeout properties were introduced to each cluster. Auto termination means when a cluster remains idle for a certain time period, it automatically terminates. Timeout feature is useful where you have sometimes your query is stuck at some point of time, which keeps on running and keeping the cluster up. So timeout property eventually kills this and makes sure the cluster goes down and doesn't remain up. Similarly, we had collated our findings from our exercise of monitoring, and we, along with Qubole team, worked on cluster-specific advanced parameter tuning. Some of the clusters were given high driver memory, and some of the clusters needed more number of cores for their efficient performance. So by default settings of Spark driver memory, number of executors being launched, garbage memory collector, all these specific parameter tunings were provided into each cluster by default. Similarly, for Tableau dashboard, which has like 24/7 up running clusters, we went on and bought some of the nodes directly from AWS so that we could always reserve and the market price don't affect our cluster pricing. This decreased our cost by around 40%. Now let us move to cost reporting. So as MiQ as an organization focuses heavily on OKRs so that the whole team can contribute towards that one single goal. Like each individual that works at MiQ has their OKRs well defined and it is linked to team and company OKR to achieve that single goal. One of the key tech OKRs is the rate of growth of processing cost should be less than or equal to 65% of the rate of growth, which makes tracking of cost all the more important. So tracking and reporting of the cost becomes utmost important in this case. So how do we track the cost? So at first, when we started this exercise, we saw that 90% of our resources were untagged, which caused us extreme difficulties as we couldn't identify like which process was being attributed to what. So now we wanted to also introduce the culture of tagging your resources properly. So hence a resource tagging SDK was written, which could automatically tag most of your resources. So these resources were five major, these tags were five major tags. One was team, product, function, owner, and environment. Once all these resources were tagged properly, we could now track our cost related to each of these tags. Uh, Qubole has that facility of cost reporting data cubes, which are quite vast, and it has a lot of info that Rohit will be covered in your debugging section. So we set up jobs on these cost reporting data cubes on Qubole. So a notebook was written which could recover the partition, and then a scheduler was formed which could update your cost reporting data cubes every day. These these schedulers were scheduled across all the all the accounts that we have at MiQ, so that each user or each team lead is aware of how much their resources they are using every day, and they can query on top of those anytime. These will be covered more in detail by Rohit in the cost debugging section. Another important tool that we used was AWS Cost Explorer. AWS Cost Explorer is a pretty neat tool that where you can track your cost, and then you can group by according to your tags. So you can find out specifically how much each team, product, function, owner, and environment has resulted in your costs. Now, once the costs were tracked, the reporting becomes important. So, a cost reporting microservice a cost reporting and tracking microservice was created, and which not only reported AWS, Databricks, and AWS costs, but also cost of other microsystems. These costs were then automatically mailed to respective teams on weekly and monthly basis. You can see a sample of this mail that is sent across to each team. So you can see that we can get we can get what was the AWS, Qubole, and total cost in the previous week, current week, and what is the growth percentage. Here you can also see the various attachments which has the detailed info, or if you want to dig deeper. Next in our journey was creating dashboards using Tableau on top of this cost reporting data cubes that were hosted by Qubole. So since these cost reporting cubes had various attributes, so we could form Databricks. We could create dashboards that were quite detailed. So for example, you can see over here, you can see that how much each team has uh, expended in each month. So these different color schemes shows different teams. Similarly, which business unit has attributed to what percentage of the cost, and similarly what is the amount of Qubole cost and AWS cost. This dashboard shows the cost distribution by engine. So how much Presto queries has costed you, how much Spark queries has costed you, and similarly Hive queries as Tez and MapReduce engine has costed you. This dashboard shows you like what is the percentage of success queries and what is the percentage of error queries. So you can further debug like what is if you see the error percentage is very high, you can go and debug what is the reason of error, and you can mitigate the issue. Similarly, we made a dashboard which showed us the on-demand and on-spot utilization and the cost associated with them. This dashboard actually shows you like how we have used our Qubole. So like how much percentage of cost was attributed to API calls, how much was through UI, how much was through direct commands, scheduled commands, and stuffs like that. This dashboard captures the how much which instance types had attributed to how much cost, so they can segregate like if some instance types are more used and some instance types are lesser used, so that it helps optimizing your type of instance. Now I hand over to Rohit for taking you through the cost debugging and wins section.
Thanks, Bitanshu. Thanks for taking through the detailed journey of cost optimization as well as the reporting. So talking about cost debugging, I think if you guys remember, the third pillar was cost debugging, and we had put a blanket around it saying self-served. It becomes very important as an organization for us so that we don't have a dedicated resource or a team to manage these things. Rather, we also build around automations and the framework so that we can enable our respective teams, or let's say team leads or the developers, to debug it themselves, right? While optimization and reporting kind of give a very vast perspective of how the cost looks like, but it's equally important for us to start debugging whenever there is a shoot up in terms of any infrastructure or a pipeline cost. So moving ahead, I think with respect to cost debugging, we have done multiple things. I think we have set up monitoring and alertings. Some of these are actually real-time monitoring and alertings. We have set up Tableau dashboard alerts. So the Tableau dashboard that Bitanshu took you through on, right? They actually have various versions. I think the version you saw is an executive version, and then there is a various version in terms of that dashboard, which is team-specific version, right? And each of the teams have placed a alert. Like let's say an alert is if the usage per day per team is going beyond this much. Let's say if the usage of particular user on a particular day is going beyond this much, right? So these are the level of detailing alert in terms of all dashboards that have been set up. And then cluster config changes alert, right? So because we are a not bigger and a small scale organization. So for us, infrastructure is slightly transparent. What I mean by transparent is that our users have an ability to see the cluster. Our users have also to some extent have an ability to optimize or change the clusters whenever needed. And that's where for us, data engineering, being the administrator of this cluster, need to know if things are being changed in the right direction or not. And that's where we have set up alerts on those things as well. That if we see that there is a cluster being changed, and let's say if business analyst or a data science team member has missed, or let's say by mistake has put down an advanced level cluster property which can take a huge toll on cost, we actually come to know about in real time, right? So these are some of the ways in which we try to contain the debugging ones. Moving on, what you're seeing here is a very good view of the cost reporting cube that Qubole has released. I think they released it quite 6 to 7 months back. I think very advanced level of optimizations done around that. We have built, let's say, pipelines where each of the leads, each of the accounts are getting their cost level information. And it's not only Qubole, it goes down to your Qubole, your AWS. As you can see on the screen, things are detailed at a user level, time level, status level, what were the commands executed, and then you have things like how much QCOH, how much vCore, etc. were used, right? So these are some of the snapshots of details around what are the various pivots and the various informations that's being derived. At the same point of time, I think what we have done is expose that cost explorer cube to multiple users, right? It's not something that only data engineering team takes a look at. It's quite transparent and people have an ability to go query and use it. So what you're seeing right now here is probably a wiki and a guide that we have published to our users. And these are some of the queries that any user in our organization can go in and on that. What you can see is that any point of time, anyone can check what's the overall cost of the account, what's the overall cost by date, right? To give you slightly more, what's the user level cost by date? What's the cluster level cost by date? At the same point of time, it's not only about cost. In order to check balance your cost as well as the skill set of your developers, you'd want to know that how many queries on a day in day out level are failing or passing. And that's where it also gives you an ability to check the learning curve of a developer, so that if let's say today he has 20 queries failing on a day, and over a period of 6 months, if it's from 20 it comes down to 10, you know that the training etc that you have invested in the particular individual are tending to show results. How do you track that? Is through this excellent cost explorer cube, right? What you can see here is at a user level, at an account level, at a query level, we are getting status by date. So this is where, as an organization, I personally don't do, or let's say data engineering team doesn't do. It's left open to everyone and anyone who can go and check these stats on. And that's about the self-serve mode that we have been talking through. Moving on. I think we keep talking about infrastructure, but at the same point of time, storage is quite important. Network is quite important, right? And there are decent amount of cost that comes along with it. So what I'm showing you here is what we use to debug cost of an S3 if there is an increase or decrease. It's a technology wise, it's a mix of CloudTrail, S3, and Athena. So basically, you enable all of your activities that goes down into a meta repository in AWS called as CloudTrail, and that information is dumped into your S3 bucket. Now, if you want to query on day in day out level that how many events have happened, how many put objects were done, how many delete objects were done, which user is doing it by which day, right? So it's a very beautiful interface through Athena that you can connect to CloudTrail and be able to run queries and then get any detail that you want. And that's where we have built an automation for S3, where at a daily level we get a report in terms of each bucket, what's the cost, each bucket, how many put events were done, each bucket, how many delete objects were done. And what you're seeing is a very sample query. You can see that it's very easy. What I'm trying to do here is that I've taken a table, mounted over a day, and then I'm trying to see which particular bucket, which particular user has been using how many events for. So that's how we typically debug an S3 cost and build an automation around that, so that we don't have to do manually. Rather, we keep it in check. Like we have a cost reporting dashboard where we can go and see, and also have an alert if the cost of S3 has increased per user, per IAM role, etc. per day. Right. As I said, this is for storage. Equally, at the same point of time, network also becomes important. And I'm just giving you an insight into how we typically debug network-related cost. One ideal scenario is, let's say, suddenly, if you started receiving terabytes of data through your network, right? Your VPC cost increases, your route table cost has increased, your network ECLs are showing some spikes. And then how do you debug? From which IP are you receiving the more data? From which IP are you sending more data to? And again, what AWS has built is something called as Insight service on top of CloudTrail. And what you're seeing on the screen is exactly that. So you have an ability to write a query language that they have exposed, and then see that how many data was transferred on a daily level from which destination or which source. So what you're seeing here is the source address, destination address, and how many bytes were transferred. And it's very easy from the query language that you can see on the top that I have written to figure out these kind of details. And now on top of that, we can export that result. What you're seeing is that you can add it to a dashboard, export it as an alert, put it into Grafana, export an alert so that you get in real time notified if there is suddenly a network added to your, let's say, VPC, which has started to ingest more volume or which has started to outbound send more volume, right? So, yeah, I mean, this was how typically our cost debugging setup works. A lot of automation, a lot of alerting, a lot of monitoring around it. Just to conclude, talking about some of the wins, especially in the current state of play, right, where COVID has kicked in and you want to focus on how do you make sure that your business is impacted. But in order to suffice your business, you cannot keep on increasing the cost. You probably have to figure out ways in how we can decrease the cost. And some of the things that we have talked through right now, a lot of these things have gone around in last 6 to 8 months, and tremendous amount of win. You can see following in the following up slide. What you're seeing here is our overall cost, right? What you're seeing here is in January and February, when the usage was high, but when it was business as usual, you could see the graphs are very high, and then you can see that how we were prepared in advance with respect to what are the optimization that we should do, how these monitoring and alerting helped us, and what you can see is from the COVID era, right? From the March, you can see the trend of going downwards. And as a business, we have started to hit back on our business as usual. And you can see that from July and August, it is not taking a sharp turn, but again, trying to see an increased trend. So, I mean, just keeping a check, just being prepared about your cost optimization, debugging, and reporting. I think these are some of the results that anyone can be proud about, right? That the moment your COVID scenario kicked in, and what you have been able to do is kind of with the business revenue, you have been able to keep a check on your cost control in a real nice way. And that's what this graph is kind of depicting. Just to show you a bit more in a detail level again, right? All those infrastructure details and the optimization detail that Bitanshu talked about. This is a very typical EC2 instance, compute engine cost. And again, what you can see that till February we had this thing, but then after that there were a lot of optimizations that been brought on. That in terms of compression, in terms of optimization, joining strategies, buying reserve nodes, Redshift applications, Druid converted into a Presto stack, and that's what is visible on your screen right now. That there is a tremendous decrease from January and February, and we have been able to keep our revenue and our cost check perfectly in balance, right? So this brings us to the close end of the session, guys. Thanks for listening in. Feel free to share our session using this hashtag. Interact with us using the Slack channel. Feel free to, I mean, find us through LinkedIn. More than happy to share any thoughts, any journey. We have a special dedicated MiQ Medium blog. A lot of informations day in, day out. We kind of try to publish there as well. And finally, thanks to Qubole for hosting this session. I think loving the energy, passion, and amount of information we are able to share with each other. So, yeah, thank you. Thanks, everyone.